Have you ever wondered what we're made out of? And no, before you think of all the answers that can come into your head, such as, well, I'm made out of sugar and spice like the Powerpuff Girls, or I'm made out of uh, iron and hard work, dedication. So many people will say a variety of things, on a figurative sense at least. But when you ask the scientists, they'll start giving you different answers. Chemists, for example, will tell you some list of elements that I won't begin to try and name. And then you have your physicists who they just want to make sure that when they break something down that there is no way to go any further, right? The fundamental principle of what we're made out of. Hi, Speech 100. I'm Michael, and today we're going to be talking about the origins of the universe, the building blocks of the universe, and the title that it is given, known as quantum mechanics. So, to start this conversation off, we need to take it into a context of, well, back to that question of what are we made out of, right? Even on that periodic table of elements, it doesn't stop there. That's not how we should classify nature. As a matter of fact, nature itself thinks that's a silly way to quantify nature. And I took that quote straight from one of my favorite lecturers to listen to, Dr. David Tong. But that's besides the point. Nature thinks this is a silly way to organize nature. We prefer to categorize nature. When I say we, I'm referencing physicists and people of like-minded physicist mentalities like to classify nature on the molecular structure, because although this sodium is different from this uranium, they both have atoms and they both can be taken apart on a molecular level. So that's what we should really be starting with when we're talking about what are we all made out of. Me, you, the dogs you see walking back and forth. What are we made out of? Well, let's take it first with the atom. We, and I'm sure for some of you or many of you, you've all heard of atoms. It's usually covered in our introductory to the applied sciences and the physical sciences when we're going through school. But we're going to go and refresh that. So the atom in and of itself is a grouped category for how we situate and organize nature. So with that atom, there is in the center a nucleus, and this nucleus is extremely tiny in comparison to the overall makeup of the atom, right? And then around this nucleus, we have a cloud. It's usually drawn as like a circle. Maybe some of you have watched Jimmy Neutron. You'll see like when I guess the cutscenes and there's like the little spirals and things of that nature, and all these rings and loops around this ball in the center. That's an atom, right? And that's how we usually depict the atom. But that ball in the center, which is known as the nucleus, which we're going to get into here shortly, is very tiny. Rutherford, he likened it to thinking of it as a fly in a cathedral. And the cathedral would be the electron cloud that floats around it. That's another thing. The electrons don't kind of go in, linear and circular set motions around this nucleus. They kind of float around like a cloud, kind of like how oxygen in the air floats around us. It doesn't go in these circles, so to speak. So, the electron. We have yet to find anything smaller than the electron. So the electron is going to be the first thing that we are all made out of. On a fundamental level, we all contain electrons. Everything in this universe contains electrons. And that nucleus. So are we done? I don't think so. With the nucleus in and of itself can be taken apart even more so. So within that nucleus, we have two more particles known as the proton and the neutron. And we would think, okay, Michael, then perfect. So we're made out, everything in the universe is made out of electrons, protons, and neutrons. And I mean, you're right. But we're trying to analyze things on a fundamental level, meaning that we cannot go any further than what we already have understanding of. So, that being said, it does not stop with the proton and neutron. Those can be fundamentally dived into even more so. And within those protons and neutrons, we have another particle known as quarks. And these quarks have numerous names. There are numerous types of quarks. There's the up quark, the down quark, the charm quark, the strange quark, and the top quark and the bottom quark. Now, the up, down, top, bottom, charm, strange, none of these have any real application to the quarks being named. The up quark isn't higher than the down quark. The top quark doesn't sit on top of the bottom quark, nor is the charm quark charming and the strange quark socially awkward. But more so, just as scientists have, I guess, moved on, they have moved away from the classical Greek educations that named all the prior scientific discoveries, and we just decided to give it those names. Now, that, my friends, would be the answer towards what we are made out of. And even that isn't fundamental in and of itself, because then there's the topic of fields that we all operate on. But that's also going to be a conversation for another time, as quantum mechanics is such a huge topic, and it's hard to get into all the intricate findings of quantum mechanics without talking about it for hours. Even when we talk about it for hours, it's hard to verbalize exactly what goes on in quantum mechanics. That's why we have yet to do things like invent or complete quantum computing, because, to be quite honest, it's hard. The mathematics required in order to fully grasp quantum mechanics is difficult. We can appropriate and get close to calculations of certain things, such as certain properties of the electron, but we can only get that within about 3%, even though we have the equations and the formulas and they are, from what we can understand, correct. It's still hard for us to get accuracy, 100% accuracy, and that's quite simply because we just don't fully understand it yet. But that being said, fundamentally, if someone was to ask you, what are you made of? You can joke, and if you want to be funny and have a physicist response, you can say electrons and quarks. What about you? I think the same. I personally have a lot of expertise and knowledge in this topic because I myself am finishing my degree in software development with the end goal of going into quantum computing myself. I want to be a part of this new frontier of scientific evolution, and because of that, I spend a lot of time following physicists. I look into the teachings of Michael Faraday, who was just an absolute genius of his time. David Tong, I might have mentioned him a little bit earlier. I quoted him earlier with nature, thinking this is a silly way to organize nature. He has a great talk that he gave at a lecture he gave at the Royal Institute. I will attach the link in my outline of this informational briefing, but there's so many physicists who are just working hard towards trying to make quantum mechanics more understandable and more accessible to the general public, and I personally would like to be a part of that. And I think a part of me being involved in making it generally acceptable is by doing the research. So I have all the qualifications needed to give you guys an introduction to quantum mechanics and to ignite that internal curiosity for more information and have all the accolades and resources available that you can use in order to better understand the scope of what we have just discussed. My name is Michael. Thank you for your time, and I hope you all have a wonderful evening.